In this lesson, we will learn about automatic site coverage. First of all, we will learn about the site coverage algorithm. Then we will perform a hand-on lab where we create a new empty site named VPN. In the VPN site, we do not put any domain controllers in it, and we will see which domain controller from which sites in the ID forest registers its service records in the VPN site. Next, we will learn about the catch, timeout, and closest sites. And finally, we sum up our lesson with the keynotes. The site coverage algorithm stated like this. Every domain controller in an ID forest must follow the site coverage algorithm to determine if it should register its service records to a site with no domain controllers hosting its domain. First of all, it needs to build a list of target sites that have no domain controllers hosting its domain. Then for each target site, it builds a list of candidate sites that have domain controllers for its domain. If no candidate site found, then it does nothing. So in this case, the domain controller has the target site contain only one site, which is the site name D, and it has a list of candidate sites containing site A, site B, and site C. Now the domain controller will perform the candidate site selection. First, it will select the candidate site that has lowest signing cost to the target site. In this case, site A, site B, and site C has the same cost of 100 to the target site D, so it will keep site A, B, and C in the candidate site list. If more than one site with the same signing cost, it will select the candidate site with the highest number of domain controllers. In this case, site C has only one domain controller. Site A and B have two domain controllers, so it will drop site C from the candidate site list. If more than one site that have the same lowest signing cost and the same highest number of domain controllers, then the chosen candidate site will be the one appears first alphabetically. So in this case, it will drop site B because site A appears first alphabetically. If the current domain controller is in the chosen candidate site, it will register its service records to the target site. In this case, site A is chosen. If the current domain controller is in site A, it will register its service records in the target site D. Let's now perform the hand-on lab by creating a new site named VPN. To do that, we need to right-click on the site and select New Site. And here we type in the site name VPN and we choose the link name Aurora-Chicago for now, then click OK. Now we open the inter-site transport and click on the IP. Then we create a new site link named VPN-Chicago. And here we select Chicago and VPN size and add it to the link and click OK. Now we need to remove the VPN site from Aurora and Chicago site link. So we just remove the VPN site here and click OK. Now we open the subnet and right click on the VPN subnet and right click and click properties, and we switch it from Chicago to VPN site and click OK. That's it. After adding the new site named VPN, here is the current site structure of our ID forest. As you can see, Chicago acts as the hub site. The signing cost from Chicago to VPN is 100, With the default configuration, bridge or side links, the side cost from Elgin to VPN is 200, and the side cost from Aurora to VPN is also 200. Therefore, for the domain itlifeskills.local, SHE-PVDC01 and SHE-PVDC02 will register their service records into the VPN site. And for the domain hq.itlifeskills.local, SHE-PVDC11 will register its service records to the VPN site. Now let's verify our configuration. To do that, we need to click on the forward lookup zones, then click on the domain itlifeskills.local and click on underscore size and click on VPN and click on underscore TCP. As you can see, only two domain controllers, SHE-PVDC01 and SHE-PVDC02 register their service records to the VPN site. Now let's click on the domain hq.itlifeskills.local and click on underscore site and click on VPN and click on underscore TCP. As you can see, only SHE-PVDC11 register its service records in the VPN site. Let's look into this scenario where the VPN client in the domain hq.itlifeskills.local attempts to contact SHE-PVDC11 because SHE-PVDC11 is in the closest site. However, SHE-PVDC11 is offline. Therefore, the client queries for a domain controllers in the domain hq.itlifeskills.local, and it receives a list of domain controllers and it tries to contact LHPVDC02. LHPVDC02 is online and it forms a secure channel to authenticate the client, and the channel has the timeout value. After being authenticated by LHPVDC02, the client stores the domain controller information in the cache. It has the DC name as LHPVDC02, the site name is Elgin, and the close size timeout is 15 minutes by default. As you can see, LHPVDC02 is not in the closest size. Per Microsoft, the netlog-on service in the client only attempts to find a closest domain controller when either of the following events occurs. An interactive log-on process uses pass-through authentication on the secure channel, or the value specified in the close size timeout registry entries has expired. This is the end of this lesson. Let's read the keynotes.